Hi there. So last time we were talking about correlation and we did some scatter graphs. We're staying with scatter graphs, but one thing we had to do last time was draw on a line of best fit. And it may have occurred to you that just doing it by eye, is there a better way? And there is. In fact, there's more than one better way. The one we're looking at today is called linear regression. Now, you can whack it into the calculator and find out what it is, but you don't actually have to do that for the exam, so we're not going to bother. I'm going to show you a little bit about how it's worked out, just so that you've got something to know it of. And then we're just going to look at the sorts of questions you're going to have to answer. Most of it fairly common sense type stuff. Now, it is important that whilst you don't have to work out the regression line, that you understand a bit about how it's worked out, because these predictions we only make for y from x from this regression line, because the way it's worked out is what's calculated is the vertical distance from each point to where the line of best fit is going to be, or where the regression line is going to be. And the regression line is drawn where the sum of the squares of those distances is the smallest. And what that means is we're always thinking in a x is input, y is output type way. If you know what x is, from that you can predict what y is. That's the idea. Right, here's the first question. So do please pause and have a go at all of this, because as I said before, element of common sense about a fair bit of this, and you kind of do know virtually all of it already. So first up, the correlation between the daily mean wind speed and daily maximum gust. It's positive. You just need to say that and put in the mean wind speed and gust into that. So that's describing the correlation. Interpreting the line is another matter. Interpreting the value of the gradient. Well, that's what you're timesing the wind speed by, which is w, to get that. So that's like the gradient on y equals mx plus c. So every time your wind speed w increases by one knot, you're expecting the daily maximum gust to get 1.82 times bigger. So it's making almost double the difference on it. So I've gone with an increase of 1 knot for the daily mean wind speed produces an increase of 1.82 knots in the maximum gust that day. You could, if you want to be fancy, say 2 knots makes 3.64 or 10 knots makes 18.2. All would be fine. And finally, justify the use of a linear regression line in this instance. Well, the data all falls along the line of linear regression, so that would suggest that a linear regression line is appropriate. It falls in a straight line basically, so you can use a straight line. So something like this. The data is all close to the line, so a linear regression line is a suitable model. Here's the next question. Take your time, write down what the equation is, have a good look at it and see what you think. So they've asked us about two babies, one born at 39 weeks and one born at 30 weeks. So the one born at 39 weeks would be just there. We've got lots of data around there, so that should be reasonably reliable for what we've got going on. Whereas the one born at 30 weeks, we've got no data for babies born so early. So from that point of view, it would not be suitable because it wouldn't be reliable. There's one other thing you could say though as well. This is a very small sample, so that would call into question the reliability for either of them. Depending on how many marks, if there were 3 marks needed, you'd want to put all those things in. If only 2 marks, then you wouldn't have to do all of them, just as many points as you need for that many marks. And the part B, explaining why the regression equation given is not suitable for this estimate, we're told what the head circumference is and going the other way. That's because everything's been done vertically. So this equation is for finding y, not for finding x. So it's going the wrong way. So I've gone with, you should only use this model to predict y given a value of x, not the other way round. Right, this is the last set of data we're going to look at for today. There's a few more questions on it which I'll introduce later, so have a go at the first two first of all. So since this is a negative correlation we've got going on here, negative gradient, I've written an increase of 1% relative humidity typically corresponds with a decrease of 106 decameters in visibility. If you've not met decameters before, you don't need to worry. It's just another decimal unit. Now it says use your knowledge of the large data set to explain whether there's likely to be a causal relationship between humidity and visibility. Now you really need to think about what these things really mean. So humidity is more water in the atmosphere, isn't it? And visibility is how far you can see. So it makes sense that if you've got more water in the atmosphere, it's going to be a bit foggier, a bit more cloudy, and that's likely to affect visibility. So we need to write something along those lines. So that's what I've written there, but I've also used the language that's there in it, and remembered to answer the question, because that first bit about more levels of humidity making it foggier and cloudier decreases visibility. So therefore we have to have a conclusion about whether or not there's going to be a causal relationship. So then I've said there is likely to be a causal relationship. So we've given a reason for it because it is causing it. Okay, so I have a go at giving some reasons why it wouldn't be reliable to use this regression equation to predict 1, the mean visibility on a day with 100% humidity, and 2, the humidity on a day with visibility of 3000 dm. So there's two different things going on here. The first one is that 100% humidity is more than we've got data for. But that would have been going in the right direction. You're told the humidity, you work out the amount of visibility. You can't use it to go the other way from visibility to humidity. You'd need to rework it out the other way to do that. So I've gone very simply with there's no data for days as humid as 100%, and the regression line has been calculated to predict V given H, not H given V. To make sure of 2 marks on the first one, it might be good to use the word extrapolation. That's what it's called when you go beyond the data you've got. So if we just write we should not extrapolate, that would definitely cover that. Okay, just 2 more little bits to go. And when I said 2, I did of course mean 1. State 2 ways in which better use could be made of the large data set to produce a model describing the relationship between humidity and visibility. Okay, so they've only used data from 2 weeks in September. So we could use more data from all of September, or actually the large data set you need to be aware of. Have a look back at the front cover of it, and it does say that it uses data from May to October, and so you could use all of that. And in fact it's got data from 1987 as well as 2015, so you could say something about comparing the data you've got with the data from 1987, which would give you a larger amount of things to make a more predictable thing from. So I would go with something along the lines of this. The data is only useful for predicting 2 weeks in September. Random values could be taken from the rest of the month. If you want to talk about the whole 6-month period, you can do. Data from 1987 could also be used. Okay, that's it for now, folks. See you next time. Cheerio.